Power electronics, machines and drives, PEMD, are essential for meeting the challenge of climate change and present a huge opportunity for UK manufacturers to be at the leading edge. Driving the Electric Revolution Industrialisation Centres, or DERIC for short, has been set up as part of the Driving the Electric Revolution Challenge by UK Research and Innovation to help companies seize new opportunities in electrification. DERIC is a front door for companies, covering sectors across transport, energy and industry, providing access to the cutting-edge equipment and academic and industrial expertise of our network partners. The partner network provides open access to over £300 million of PEMD capability and a further £28.5 million in filling key gaps for manufacturing and quality development. We're here to support your growth plans for the electric revolution.
The Driving the Electric Revolution Challenge has been established to encourage cross-sector collaboration and accelerate delivery and growth of UK manufacturing capability in power electronics, machines and drives technologies, or PEMD. Advances in UK PEMD technology development and domestic supply chain are imperative to ensuring that the UK continues to be at the forefront of electrification of transport and improvements in efficiency and capacity of the energy and industrial sectors. The time is now to make meaningful change in order to meet net zero targets in the future. Our role is to help ensure that the UK PEMD supply chain is equipped and ready to do so. DERIC has 4 regional centres located in Scotland, the North East of England, the Midlands and South West in Wales. The DERIC network of partners supporting the 4 regional centres is extensive, with more than 30 academic and RTO partners involved. Each regional centre carries a specific focus, which for Scotland is high power, high integrity and systems. Therefore we are focused on rail, aerospace, maritime, off-highway, truck and bus, in addition to energy and industrial sectors. Achieving net zero presents different challenges for each sector, and some will be doing so in light of recent disruption to normal operations introduced by the COVID-19 pandemic. Across all of these sectors, there will be shared challenges, common solutions and universal benefit in a joint approach to developing the technologies and supply chain that will enable all sectors to achieve their goals. UK Research and Innovation have awarded £28.5 million of capital funding for equipment that will further enhance the existing operational facilities. Building on existing centres of capability ensures rapid start-up and fills key capability gaps so we can accelerate and de-risk our industrial partners' production plans. We expect some of this to be operational later this year, with long lead time equipment on stream by mid-2022. The aim is for our OEM and prime partners to access the capability themselves and to encourage their suppliers to do so too. This will allow smaller manufacturers and technology companies with technology development and manufacturing ambitions to demonstrate their capability to scale up and grow UK content in PEMD products. This is a long-term endeavour. Our vision is to put the UK firmly on the map of global PEMD manufacturing capability. Our regional setup allows us to be more accessible to industry clusters, to support all levels of industry, signposting our capabilities, deploying our collective expertise through collaborative projects and leveraging national, regional and devolved funding. We have more than 20 academic partners and 14 RTOs in our network. Collaboration is hugely important, with successful collaboration ensuring better use of government investments, sharing of equipment and more collaborative project delivery. Here in Scotland, our expertise is underpinned by capability and facilities across 4 universities. The University of Strathclyde, including PNDC and the National Manufacturing Institute of Scotland, University of St Andrews, including the Hydrogen Accelerator, University of Glasgow, including James Watt Nanofabrication Centre, and University of Edinburgh's Electrical Power Conversion Group. The joint capability at DERIC Scotland enables a systems approach to be taken, as the capability across our partners allows us to support innovation and test across all levels from device up to system. The capability across our network has grown with industry need and has a great track record of enabling innovation and reducing time to market of new technologies. The University of Strathclyde's Institute for Energy and Environment is focused on electrical systems through themes such as whole system studies, power electronics, machines and drives, and HVDC systems and technologies, in addition to much more. Meanwhile, the team at the University of Edinburgh's Electrical Power Conversion Group are focused on novel generator designs for renewable power generation, thermal and mechanical analysis for electrical machines, and power and conversion and control for renewable energy converters, including HVDC converters for offshore power transmission. The academic network within the DER Industrialisation Centres is vast, so I encourage you to get in touch to find the right experts to support you. In addition to the university institutes themselves, there are a range of partnerships, manufacturing and test facilities within Derrick. The PEMD part of the University of Strathclyde is the lead partner in Derrick, Scotland, and will be investing the DER grant to expand its existing capability to test megawatt scale machines and drives.
I'm Kyle Jenner and I'm an R&D engineer here at the PNDC. I also lead the team that runs the MOD research program. The power hardware in the Loop platform is useful in a number of ways. Because it's configurable, it means we can simulate lots of different power systems. We can do utility, aerospace, naval, rail, and connect in hardware that's applicable for each of those applications. So for a shipboard power system, it might be a new generator we're connecting. For a utility, it might be a unique load that may impact the power system. So it's quite flexible in that regard. The platform we've developed lets us interface power system simulations with real hardware. So it means that we don't have to connect the real hardware with the actual power system. There would be risks associated with that for users of the power system. In a utility base, that would be the customers connect to the power system. In a shipboard power system, it would be the crew of the ship. And by doing it in a simulated based platform, we avoid exposing those customers to the risks associated with connecting a new piece of equipment to their power system. There are a number of key features to the platform we've developed. In terms of the hardware interface, we have the tri-phase, which is modular and scalable. It currently has a 540 kVA capacity, but can be increased with new modules added to the system. It's also configurable in terms of its output. So it has 2 AC modes of operation and 2 DC modes of operation, which lends itself to connecting to a variety of different hardware that we want to test. The real-time digital simulator is a unique platform, and the 2 key advantages with our real-time simulator over offline simulations like Simulink is that you can run it interfaced to real hardware, so both are running in real time, and also that the development can potentially be quicker. It's made up of 3 RTDS cubicles, and it operates in both long time step simulation mode, which is 50 microseconds, which we use for power system simulation, and it also operates in a short time step mode, which we would use for power electronic switching based applications, and that can go right down to 2 or 3 microseconds.
The PNDC will benefit from the DER equipment funding to expand the existing operational equipment in the facility in order to deliver megawatt scale full systems test capability, building on the existing experience at the centre. The centre is procuring 2 megawatt scale dynamometers, 1 high speed and 1 low speed, a megawatt scale DC power supply, an environmental chamber to enable test of devices off condition, and hydrogen refuelling infrastructure for future hydrogen based platforms. The equipment specifications have been developed in collaboration with industry, with input from all of the sectors Derrick Scotland is targeting: aerospace, rail, marine, off-highway, truck and bus, energy and industrial sectors. A range of use cases were developed in collaboration with industry to understand what the potential could be for this equipment, and the PNDC plans to deliver a unique facility which is capable of testing megawatt scale technologies at a platform level. This capability will enable technology validation, accelerate time to market and reduce risk of testing and validating products for high power, high integrity sectors. The UK is home to a number of OEMs and systems integrators who will require support to develop, test and build supply chains to enable the transition to zero emissions platforms. One such company is Rolls-Royce, which the University of Strathclyde is currently supporting via the Rolls-Royce UTC.
The pandemic in 2020 drastically impacted our industry, but we also know that in the longer term the growth of aviation will resume, and with it will come the need to drive alternatives which will make our industry sustainable. For us, one of the potential solutions is electrification of aircraft propulsion. Electric propulsion is quieter and offers the benefits of reduced fuel consumption and emissions. We see new methods of transport evolving, eVTOLs complementing urban mobility changes, and short regional routes being served by air transport in economical and ecologically friendly ways. connecting communities and reinvigorating rural airports. Large aircraft classes are becoming more electric, and megawatt class power is on its way to enable hybrid electric flight across longer distances. We are determined to become a world leader in providing electrical power and propulsion systems for aviation of the future. We will help our customers launch their electrical fleets with complete systems that are scalable and modular, efficient, reliable and safe. At Rolls-Royce, we are meeting the challenge with the support of initiatives such as the DER Industrialisation Centres, which will aid the design, manufacture and test of electrical technologies, components and systems through collaboration with academia, customers and the supply chain. Building on our long-standing experience in developing certified products for the aerospace industry, our tradition as a reliable supplier of electrical power and propulsion for the marine, industrial and energy markets, and with our cutting-edge technology prototypes for flight, we have the knowledge and capability it will take. Working together with the wider ecosystem will make cleaner and more efficient flight a reality.
While the focus of DER is on the growth of PEMD, we recognise that future propulsion and powertrains are likely to be powered by a wide range of energy vectors, which all impose different requirements and challenges in product development. The University of St Andrews are a key partner in Derrick, Scotland, for providing expertise in the development of hydrogen fuel cell and battery technologies, and the impact that different options may have on the adjacent hardware in the final system. Through the Hydrogen Accelerator, based at the University of St Andrews in partnership with the University of Strathclyde, the partners are able to support research, development and innovation. In 2023, the powertrain test facility Locate will be launched. Locate is a first-of-a-kind, platform-level route-to-market testbed for battery and hydrogen fuel cell electric drivetrains, focused initially on heavy-duty vehicles. The Transport Scotland funded Locate facility will be located at MSIP in Dundee. This future open access facility will allow system integrators to test real-world duty cycles which would traditionally take place on the road. This facility has attracted leading systems integrators, Arcola Energy, to set up their new facilities at MSIP, creating around 140 highly skilled jobs in Dundee. Arcola Energy projects in Scotland include the Hydrogen Train project, Hydrogen Bus for Dundee and refuse collection vehicles for Glasgow City Council.
Hi, I'm Ben Todd. I'm the CEO of Arcola Energy. We're a hydrogen and fuel cell systems integrator. Our focus is on bringing hydrogen and fuel cell zero emission technology to the heavy duty vehicle sector. We work particularly on buses, trucks, trains, ships, heavy vehicles such as the one behind me, where we will replace what is typically a diesel drivetrain with an electric drivetrain which has batteries, as you would have in a battery electric vehicle, but also hydrogen and fuel cell. This gives you a longer range and a faster fill time than battery only, and is part of the picture of the zero carbon, zero emission transition. We're growing our work in Scotland a lot at the moment. The Scottish Government policy is very strongly set up to enable this transition. Also, Scotland has a really amazing renewable resource, so there are opportunities to grow the renewables going into the grid more quickly by combining that with hydrogen. Within the Scottish ecosystem for innovation for the zero emission transition, we find a really nice partnership between government, industry and academia. Specifically, we're working really closely with St Andrews University and the Hydrogen Accelerator, and also with Strathclyde University and the Driving Electric Revolution Centre based at Strathclyde. So very happy to be in Scotland, very happy to be part of this transition, and look forward to many more vehicles on the road soon.
The presence of projects such as Arcola's hydrogen fuel cell electric train in Scotland demonstrates that there is an appetite for new zero emission platforms to be developed and tested in Scotland and the UK. Our aim in DER is to ensure that we support Scottish and UK supply chains in playing a pivotal role in the delivery of future platforms. Mitchell and Scotland Innovation Park have recently become a member in DER to enable closer collaboration with business, working towards delivering net zero.
Hi, I'm Sarah Petrie, Innovation Director at Mitchell and Scotland Innovation Park. Our mission is to create a dynamic and creative home for innovators, manufacturers and skills leaders to collaborate and nurture growth and advances in sustainable mobility and decarbonisation. Our ambitions are to create 850 jobs, ensure skills development and retraining opportunities, and deliver significant economic benefit. And we will achieve this by building an innovation and manufacturing ecosystem in sustainable mobility and decarbonisation, both directly and through new product development and manufacturing and the associated supply chains. MSIP works collaboratively to provide tenant companies and the sustainable mobility sector in Scotland with support to innovate, manufacture and grow, and to build the required partnerships with academics and businesses to support this. Our tenants currently cover a range of technologies including battery, solar, EV charging and hydrogen. Our relationship with university partners provides companies with access to expertise and facilities to drive innovation and manufacturing. Together with the Driving the Electric Revolution Industrialisation Centres, we aim to help companies scale up the use of electric-powered vehicles and machines to deliver Scotland's ambition for zero-emission transport and our journey towards net zero.
The National Manufacturing Institute of Scotland, or INMIS for short, part of the University of Strathclyde, is a group of industry-led manufacturing research and development facilities where research, industry and the public sector work together to transform skills, productivity and innovation to attract investment and make Scotland a global leader in advanced manufacturing. INMIS aims to work with industry to increase productivity by reducing barriers to innovation, stimulate investment and increase manufacturing competitiveness, catalysing job creation and strengthening the supply chain. Additionally, INMIS aims to inspire and attract talent to ensure future workforces are equipped with the skills that they and the businesses they work for need. INMIS works with manufacturing businesses of all sizes in a range of sectors, providing benefits across the whole of Scotland and the UK. In order to deliver on these aims, INMIS is a key partner in initiatives such as Derrick Scotland, the High Value Manufacturing Catapult and the Future Electrical Machines Manufacturing Hub. INMIS is made up of a number of core elements and specialist centres, including the Advanced Forming Research Centre and the Lightweight Manufacturing Centre. The facilities house a range of specialist manufacturing and lightweighting equipment and the associated expertise in order to support industry in improving design for manufacture and the efficiency of their manufacturing processes. The role of INMIS in Derrick Scotland is to support our industrial collaborators in the design and delivery of PEMD and support our supply chain partners to develop the manufacturing capabilities required to ensure the UK supply chain is ready to support electrification. The INMIS FEM Hub team is currently focused on a grand challenge aimed at sustainable manufacturing of electrical machine components for the circular economy. The aim of this challenge is to ensure that the circular economy of electrical machines must not be an afterthought but an integral part of the development cycle. The team are taking two approaches, the first being data-driven technology developments to develop sustainable manufacturing models for electrical machines, detail potential reuse, remanufacture, refurbishment and recycling options, and use in-service data to select the most appropriate circular economy strategies. Secondly, supply chain integration and development workstream aims to begin developing a UK supply chain for end-of-life processing and collaborate with UK-based companies to develop case studies for improvements on recycling of machine materials and components. Finally, the James Watt Nanofabrication Centre, or JWNC, was established in 2005 and is a 1,400 square metre cleanroom facility at the University of Glasgow. It provides end-to-end processing capability for gallium nitride power devices and is equipped with £35 million worth of tools, supported by 22 technicians. It houses a commercial electron beam facility as well as lithography, deposition, etch and metrology equipment. Having JWNC in the Derrick Scotland team means we're able to work with industry to understand how system level requirements impact power devices and subsequently support GaN manufacturing process development. Derrick Scotland has a wide range of capability to support government, industry and associated supply chains, whether at device, machine, subsystem or system level, wherever you are in the development or manufacturing cycle. Derrick Scotland is one of 4 centres in the UK, which all act as a front door to extensive capability and equipment available to support the journey to net zero across transport, energy and industrial sectors. So please do get in touch, we're here to support you to deliver your roadmap for a net zero future.